All right, you are in the right place. You're at Resource Innovation Institute's webinar, Energy and Water Efficiency in Controlled Cannabis Cultivation. I am Rob Eddy, Technical Director for RII, and we're so glad you're here. We're very excited about this presentation today, and you'll be able to learn lots of great ways to save energy and to save water. We know from your questions to us during the registration that is a big area of importance to many of you. So we thank you for that. And this is what we do at RAI all the time, is try to find ways to make CEA facilities more resource efficient. So this is the second of two workshops for NYSERDA, and we do thank them for their sponsorship and the Office of Cannabis Management as well. We're very excited to bring this to you. Next slide, please. Here's our agenda today. I'm going to talk a little bit about introduction and purpose. We're going to have Maggie Cowie talk a little bit about their purpose and introduce her group to you. Then we're going to do a Cannabis Science 101 section. I'll do that just 4 or 5 minutes. Don't panic. It's not going to be too crazy. It's going to actually probably inspire you to know what a cool plant cannabis is, and some of the great discoveries that are being made that you can begin to bring into your craft cultivation practices. And I'll be doing a little bit about that each time we do a workshop. Again, this is number 2 of 4, so each time we'll do a little bit more of the cannabis science. Then we'll get into our technical discussions with our expert panel on lighting, on shade and thermal curtains, and on water quality and sources. Then we'll show you a few resources that you can use, and then we'll open it up for question and answer. Now, you can ask questions throughout it by writing them into the Zoom chat. And Carmen Azzaretti, who's helping me, she's the wizard behind the scene, who will be advancing the slides and making sure I don't misspeak. She'll be tracking those questions, and she will save most of those towards the end, where we'll have a 20 or 25-minute session. All right. So that's how it's going to run. Now I want to introduce Maggie Cowie, and she's going to talk a little bit about her organization to get us started today. Maggie, take it away.
Awesome. Thank you, Rob. Hi, everyone. Welcome to the webinar. Thank you for being here today. My name is Maggie Cowie. I'm an economist with the Office of Cannabis Management, and I'm heading up our energy and environmental sustainability initiatives. Before coming to OCM, I was a data journalist at MJ Biz Daily, and prior to that, I spent a couple years working and living at a small indoor medical grow in Eastern Oregon. Before that, I spent a dozen years as an agricultural and resource economist at the University of Nevada, Reno, where I specialized in rural economic development and risk management education for farmers and ranchers. Often that meant providing education and technical assistance to operators transitioning out of high water use crops into low water use crops, or transitioning from commodity production into direct markets. It also involved writing a lot of grants and trying to bring in funding to help our stakeholders and their communities. Part of the reason I wanted to talk about my background is to emphasize that we do have teammates at OCM with ag experience, and we recognize that agriculture is a tough gig. We're aiming to develop sustainability policies and programs that will protect the environment while also protecting business sustainability. If you viewed our proposed regulations, you're probably aware that a main component of our proposed sustainability regulations is requirements for resource tracking, including energy and water. The information you learned today might give you some useful tips on how to meet those requirements. In that vein, we have a Cannabis Control Board meeting later this week on Thursday, May 11th. We anticipate that the board will approve the revisions we've made to our proposed adult use regulations as a result of what we heard from more than 3,000 public comments. That will initiate a second 45-day public comment period, and we expect that the regulations will go into effect in August. We're working on guidance for our energy and environmental sustainability regulations now, and we anticipate we will start releasing information as soon as those regulations are finalized. RII allowed us to put together a follow-up survey to help us understand where cultivators are with respect to energy and environment regulations, so we can assess how to best support you get there. So when that survey hits your inbox, please fill it out and give us your honest thoughts. We've got a really great team at OCM working on these issues, and we're supported by staff members at other agencies such as NYSERDA. And I want to give a shout out to our colleague, Kathleen O'Connor, who's been super helpful to us at OCM, and also is the person who spearheaded this webinar series. We're also working with our utility regulator, the Department of Public Services, the Department of Environmental Conservation, and the Department of Agriculture and Markets, all of whom have been amazingly helpful. We're working with those folks and others to examine the potential for financial incentives to meet efficiency regulations, and we're looking at funding and financing mechanisms as well. We've also had a really warm welcome from regulators in other states who are helping us understand what they wish they'd known at the outset of their markets, and public and private partners like RII, energy consultants, architects, and design engineers. I'll close out by saying New York State Cannabis and OCM have great partners both across the state and across the country who are enthusiastic about helping us support our licensees and ancillary businesses. And we are excited to continue working with everyone to develop a sustainable state industry. Thank you.
Thanks, Maggie. And the state of New York, you guys are very lucky to have the OCM. They really, really have their act together. And as you heard Maggie said, they went and talked to other states to find out what went right, what didn't go right, and that has paid off. We're noticing it at RII because we work with a lot of states, and we are just so pleased to work with OCM and NYSERDA because everything is just going like clockwork, and it shows with the attendance at these webinars and the questions that we're getting. So thank you, Maggie. Next slide, please. Okay, I'm going to do a little bit of introduction here. So next slide. Let's talk about who we are. We're an objective, data-driven nonprofit organization. We're USDA funded. We're also looking at more federal funding with Department of Energy, if possible, and others that we're applying for to keep this program rolling and to roll out training credentialing programs along with our other education. We're founded in Portland in 2016, worked with the cannabis growers in the cannabis industry for several years, and then we were awarded a USDA grant 2 years ago and have been working with food crops and ornamental crops as well since then. We form working groups from industry, government, academia to develop these best practices guides. More about that in a minute. And then we use that as curriculum to provide webinars, workshops, write articles, blogs, newsletters to the industry. We also benchmark growers. We benchmark growers' production and resource efficiency with our PowerScore platform. So they come to us and with their utility bills, and we help them and with their yields and with their protocols, and we help come up with KPIs, those key performance indicators of how they're doing as far as energy use and water use per pound of produce or flower that they harvest. Next slide. We've got a vast network. This is what's fun about REI, that we talk with everyone, and then we bring them together for these working groups too. So we work with governments, we work with regulators, resource suppliers, efficiency programs, of course, producers, a big one, and supply chain. We get so much support from the equipment vendors and design and construction industry. It's great. And then the standards groups, and of course, academia. Next slide, please. So these working groups guide us to develop standards and climate smart methodology. We usually pick one particular aspect like lighting or HVAC or design. We bring together experts on that and then distill that expertise from industry and academia into one document. That's what RII does that not many other folks do, is that we bring together both those kinds of information. The working groups shape the tools and resources to support best practices guides, and this is important, they're advocates for informed policies, incentives, and regulations. So as we're cranking out these best practices guides, that's also great that it's informing governments about how the industry really works so that they can create regulations that are smart regulations rather than, ones that sometimes are just not so smart. So I'm very excited about that. If you're an equipment service provider in the industry and want to become a member, contact us. We'd love to have you join, and then you can participate in these working groups. Next slide, please. So here, example covers of some of our guides that we released in the last few years. Again, HVAC, lighting, design and construction, we tend to focus. on one particular aspect. In June, late June, we're going to release our most recent one. It's on water circularity. What that means is reducing water usage, remediating water, and reusing it. So how to collect your irrigation drain, how to collect rainwater, how to collect HVAC condensate, and use those so you're reducing your water footprint. These best practice guides are free. They're sponsored by the USDA. Thank you to them, USDA, because that means you can download them for free from our website. Next, please. Purpose today: help New York cannabis growers improve energy and water efficiency in both greenhouse and indoor facilities. Convey scientific insights and industry expertise. One place to get all that information and translate it into common language. Assist cannabis producers and their design and construction project partners with what they need to know to comply with regulations while staying competitive. Okay, that's the balance we try to strike. Next slide. Okay, we're going to do some introductions now. I'll go first, and then Jason, Paul, and Dane in that order as it appears here on the screen, left to right. Again, I'm Rob Eddy, Technical Director. My background is in facility management. I was at Purdue for 20 years, managing their greenhouse and growth room and growth chamber and tissue culture facility. It was great work. Prior to that, I'd worked at Dow AgriSciences, big ag chem and biotechnology firm in their research greenhouses. I left Purdue almost 6 years ago and been in consulting for the vertical farming and cannabis industries. Been a lot of fun, but it wasn't the most fun I had was working on sustainability issues. And so when RAI had a position, I jumped on it because this is very rewarding for me. Jason, can you introduce yourself?
Certainly. Hello, everybody. My name is Jason Matlock. I'm a horticulture service specialist at Fluence Lighting Company. So in my role, my job is to work with our customers to help identify and remove operational barriers to the use of our technologies, to do demonstration and research and development trials with those customers, and generally support them, before, during, and after sales. So in my role, I visit a lot of growers in a lot of different states throughout North America as well as in Europe. So I've been in probably 200 growing facilities in the last couple of years. So I got a really broad perspective on the industry. Prior to working with Fluence, I started my career off as a wine quality control chemist. Got into wine production. Actually ended up working as a brewer, ran a brewing company. Did a lot of work in production environments, scaling those environments, figuring out how to make them efficient and focus on continuous process improvement, and really developed a passion for that. And I have worked in the cannabis industry as an operations director and a grower, both in Michigan and Missouri prior to joining Fluence.
Thanks, Jason. Paul?
Hi, guys. My name is Paul. I'm Svensson's greenhouse climate consultant for North America. So similar to Jason, I go to visit greenhouses and I help them determine what kind of shade screens they might need for climate control. So on top of shade screens and climate screens, we also provide vertical airflow fans. So the main aspect of my job is to come into your greenhouse and show you or teach you or help you develop a more homogeneous climate that would fit the crop that you're growing in. Prior to this, I was a grower at a greenhouse called Metrolina Greenhouses for about 3.5 years. I mostly worked in the propagation department with lots of different varieties of crops except cannabis. So it was mostly ornamentals. But I still have a lot of experience with crops that require certain photo periods and just the technical details of young sensitive plants. I'm going to get into it a little bit more in my presentation, but we do energy calculations for greenhouses, which is one of the more useful tools that when getting rebates nowadays is definitely a useful thing. But I'll talk more about that later.
Great. Thanks, Paul. Dane?
Hey, good afternoon, everyone. My name is Dane Sheldon. I'm the Director of Business Development at Aquis Group, where we provide design, build, and service of industrial scale water purification, recycling, and treatment systems. supporting CEA, manufacturing, and marine industries. We've been in business for about 35 years, or located in Rhode Island. And over the past 5 years or so, we've been working actively in the CEA space, helping facilities develop, optimize, and maintain water systems, everything from the water purification to managing waste streams to looking for opportunities to reuse, recycle water. So we've been working with RII through the technical advisory group, developing the best practices for water circularity, and looking forward to talking a bit more today about some of those opportunities and everything going on in the state of New York.
Great. Thanks, Dane. That was great. And advice I would give all of you who are just starting out in horticulture or your first horticulture business is talk to folks like this. And we'll be providing the emails at the end. I know that when I was a young grower, the people who taught me the most were the technical reps from the company, because they actually would come to my facility and they would actually have time to answer my questions, and they weren't heavy on sales. They knew if they just if they taught me and built a trusting relationship, that eventually it would lead to sales. So I think that's the best advice I can give all of you right now. So when this webinar is over, the learning still continues. You'll have access to the New York Virtual Classroom, which has the recordings of the live workshops, some downloadable resources, including those best practices guides, and the New York State program tools. Next slide. I think we're going to get into our Cannabis Science 101, okay? Don't panic. This will be easy. Next slide, please. First, a poll alert. What kind of facility are you cultivating in? So I'm going to leave this up on the screen, and we're going to keep moving, and I'll report back on the results at the end of my section. Next slide, please. Okay, cannabis, it's a dioecious flowering plant. Dioecious, big word, that means male and female parts on different plants. With 3 subtypes as recognized by most people, most botanists: sativa, indica, and ruderalis. And noteworthy genetics are of this crop are the production of secondary metabolites. We'll talk about that. And lignin and cellulose, of course, hemp fiber, and then the amazing response to light, which I know that Jason will talk about, and I'll probably touch on for a second as well. Next slide. This is the Fluence Cultivation Guide, and this is great. I mean, this sort of table didn't exist 6 or 7 years ago when I first started getting into cannabis, so it's great that all this table tells you light intensity, CO2, temperature, relative humidity that they recommend based on different stages of growth, right? Carmen, tap on the next. We got some highlight boxes. So under the flowering, a couple things I want to point out. This is kind of interesting. Next one, please, Carmen. So this is strange. It just says 600 plus light micromoles per meter second is the unit of light. Full sun in July, in the middle of the day, is about 2,000, so 600 plus. That's helpful, but it's not. Sometimes you think, well, why isn't it more specific? Next, please. Press that next button. Same thing with temperature. It's a big range. Well, the reason you see that is not because we don't know, it's because those things interact with each other. Temperature, light, CO2. And so how much light you use kind of depends on how you like to grow, kind of depends on your temperature, kind of depends on the CO2 level. If you want to optimize growth in cannabis, you crank up the light, you crank up the temperature, and you crank up the CO2. You know, that is the way to get lots of yield. It also burns a lot of energy. What's fun is that once you begin to learn these concepts, you realize that you can play around with it, that you could use CO2 in replacement of high light and in replacement of high temperatures, and still get normal yields while reducing your energy load. So the same building that you design, I suggest to you that you can design a facility that can optimize growth or could also keep your production costs down. And our panelists will tell you, you'll get ideas on how to do that. Next slide. So the flowers are what we really want with cannabis. That's where the cannabinoids and terpenes are concentrated, in the flowers. Okay, next slide. What I want to point out is that growing cannabis is not that much of a mystery. Cannabis is an amazing plant. We'll talk about it, but this production of it is not, it's not brand new stuff. It's similar to cut flower production of many crops, including cut flower chrysanthemums. Same thing. They need, they grow vegetatively, and then you start pulling a light depth cloth to get them to flower. Look at those strings holding up the flower stems. That look familiar? That was invented for cannabis. That kind of network string has been around for decades for the cut flower industry. All right. Next slide, please. And look at this. This is 99 years ago. This is they're growing chrysanthemums this way 99 years ago. I've just put this on there for fun to point out that this isn't brand new stuff. Next slide. So here's what's remarkable about cannabis. These are discoveries that have just been coming out the last 3 or 4 years. I worked at a research greenhouse. I grew about every plant under the sun except for cannabis, and the crops that could take a lot of light, were corn, as you would imagine, and rice. When you think about where those grow, it's like you can just throw as much light at them as you want, and they'll keep increasing their photosynthetic rate. They got lots of different new ways they evolved these different mechanisms in order to be able to take advantage of that light. And they're both kind of grass plants when you think about it. Rice and corn, they're actually grass plants, but cannabis rivals them, and they're not. And cannabis is not a grass plant, obviously, and no one quite knows why this happened. But look at this graph. This is a measure of as you increase that horizontal line is the amount of light. PPFD means light. So as you increase light, the photosynthesis, which is on the y-axis, the vertical axis, the photosynthesis increases. This is for soybean until you get about to 500, 700 micromoles of light, and then it doesn't matter. You throw more light at it, it doesn't do anything else. It doesn't photosynthesize more. The effect is saturated, as they say. So that's soybean. Carmen, press next. This is cannabis. Just remarkable response to light, okay? And no one quite knows why this is. And in fact, when you start thinking about the entire canopy of cannabis plants, basically you can keep adding more and more light all the way up to that 2,000 micromoles, and it still continues to increase its photosynthesis and yield. Next slide, please. So, and this is why it's important. It's been a truism for a long time. It improved scientifically in the last 20 years. An old truism about 1% increased light increases yield by 1%. Well, that's turned out to be basically true. So when you think about what I just showed you, you can by increasing light, you can increase yield. So the question is how to do that in a smart way. All right, that you're also not blowing up your energy bill. Secondary metabolites are created. A lot of plants create, well, any plant will create secondary metabolites. First of all, what are they? Well, what are primary metabolites? That might help. Let's start with primary. That's the stuff that plants need to grow, and reproduce. Chlorophyll, DNA, sucrose, those are primary metabolites. Stuff that plants make to carry out their life cycle. Secondary metabolites are defense compounds. The plant really doesn't need to make them. It just, since they can't run away from danger, they have to fight it chemically. So when they're exposed to stresses like heat or cold or drought or even animals chewing on them, they release defense compounds. The reason those dollar signs are there is making these costs the plant a lot of energy and a lot of photosynthetes, a lot of sugars. It costs a lot, so they don't want to make these when they don't have to. Next slide. So, but what's interesting is that, again, remember those stress creates new plant chemistry. And they've shown this with this picture on the left. This is red lettuce. It's supposed to be red. You can get a lot of money for it. You can sell it when it's red. Customers want that. The problem is greenhouses tend to be low light and kind of dim in the spring when you're growing these things, and they don't turn red. So they figured out that, well, you just expose it to some blue light in your lighting mechanisms in the last few days. You don't have to do it the whole time the lettuce is growing. Just in the last 5 days, you can get the green lettuce that's supposed to be red to actually turn red. And that's a stress response. It's making anthocyanins, which are purple in response to that. Well, there's purple, strains of cannabis. Does it work there? Well, MedMen did studies on this and found some interesting results. They wouldn't tell us what they were. Of course, it's their IP, but there we go. They're using stress to induce new changes in plant chemistry. Next slide. One more for you. Controlled drought stress. One event of drought stress, basically letting the plants in week 7 of flowering wilt just once, just when the leaves begin to droop a little bit, and then continue on with your normal watering. Just doing that once was shown at University of Guelph to increase THC by 50% in the cultivars that they grew, the strains, as you would know them, and in CBD by 67%. Remarkable. Again, stresses make new chemistry. Next slide. Okay, Carmen, let's see the results of this poll. So most are doing are cultivating a small indoor building, followed by an indoor warehouse, and then by standard vented greenhouse. Great. Thank you for answering that, everyone. We really appreciate it. Next slide. Before we get started with Jason's presentation, we're going to have another poll question. Can you put that up, Carmen? Next slide. Okay. Actually, this will be a knowledge check. Okay. Compared to field crop production in the summer, a greenhouse has about the same insect and disease problems, has less, has more. Just want to see what you think about that without anyone telling you. Okay. It's a comparison between a greenhouse and a field. All right. Next up is Jason with his presentation on lighting. Take it away, Jason.
Hey, everybody. So just a quick little bit of context here. Rob mentioned our cultivation guide from Fluence, the fact that there's all this range of things that you can do. He talked about stress responses and manipulating and steering the crop with light. So those are all things that we have content on and can talk on. And you can go on for hours. So I have 18 minutes. So we're going to dive into a very specific niche of this, but there's a lot more to discuss. But what I want to talk about is that at the end of the day, we're focused on commercial production and optimizing commercial environments. And if you're not making money, then you're not going to be successful. So Fluence's perspective on lighting is really focused on creating an economically viable solution for growers and doing our best to ensure that our products are integrated in a way that drives the bottom line. So when you start thinking about manipulating spectrum, when you start thinking about steering crops or gaining yields, all of those considerations have to be tied back to economics. So the answers I think that we will give and may present as industry professionals may differ from those that we would give if we were speaking about a small garden or a small plot, because you're less concerned about the economics. Again, if you're not making money, you're not going to be successful. Lighting is a big part of that, and we have to balance functionality, performance, and economics. So that's just something I want to point out to everyone as they're thinking about what to do and what solutions to invest in, is to really tie that back to your bottom line and your goals. The other thing that we'll talk about here in a little bit is quality and the impact of quality above and beyond yield. But as a starting point, let's talk about light. So there's a lot of different ways to talk about light, a lot of different ways to measure light. There's a lot of units for light. There's lumens and lux and foot candles and watts and all sorts of things, and they all measure different stuff. What we care about in this space is plants. We're growing plants and we're using horticultural lighting to drive plant growth and development. So our metrics need to relate to what the plant is doing so that they're meaningful to our application. So in the case of plants use a very specific portion of light. They use 400 to 700 nanometers. So those are the wavelengths of light, which we can roughly break down into colors based off of ranges of wavelengths. So you got UV is kind of smaller than 400, and that's UVC, BA. There's blue, that's 400 to 500, green 500 to 600, red 600 to 700, and then far red, which is kind of like 700, 800, 850. So that's sort of our range of light that the plant is working with. And that range we call PAR, photosynthetically active radiation. So when we're measuring light and we're talking about working with light, from a horticultural perspective, we need a unit that focuses on PAR, because the plant uses photons to create fuel and to drive its metabolism. So we care about how many photons the plant is getting and what it's getting in that range. Everything else doesn't really matter. So if we advance forward real quick, one more click, there we go, perfect. So the first unit I want to talk about is photosynthetic photosynthetic flux density. So in this case, we can relate this to kind of like a rainstorm. We think about light as a rainstorm. Your light fixture or the sun, whatever your source is a cloud. And that cloud rains down photons. Photons are little packets of light. You can think of those as the drops. So the first measure, PPFD, answers the question of how hard is it raining? Is it a drizzle? Is it a thunderstorm? And this has the units of micromoles, which is the number of photons per meter squared. So the area that it's raining in is standardized, and then per second, per time. So quantity, area, time, PPFD, micromoles per meter squared per second. So let's talk about what that range looks like. As Rob mentioned, roughly 2000 is bright light, bright sun. But we as humans use light to see, not do work. So we're really good at working in a range of light. Moonlight's about 0.1 micromole per meter squared per second. Candlelight is, in the ones. Your indoor environment with the shades closed and some artificial lighting is 5 to 10. Outdoors under a tree or in the shade, 50 to 100. A decent day, 500 to 1500. And the brightest places on the planet are somewhere in the 1800 to 2200 range. Maybe you see 2500 at the top of the tallest mountain on the clearest day at noon. So we have a pretty broad range. We have a terrible ability to see light as humans. So you really need to measure your light with a meter, and you need to measure it in PPFD in these units for PAR light specifically in order to work with light. Next slide, or next, please. So another unit that's relatively important is looking at DLI, daily light intervals. So PPFD measures how much is it raining or how hard is it raining right now. DLI measures how much did it rain today. So if we put a bucket on the ground, how much did that bucket fill? This is really important for crops, particularly greenhouse grows, where you have variable amounts of light. Plant response is largely associated with how much light it gets in a day, not necessarily how intense that light was. There are implications to light intensity, but growth in general is patterned around DLI. So it's a similar measure. It's moles instead of micromoles. So it's still a quantity, still meters squared, so it's still area, and it's day instead of seconds. So it's how much light did we accumulate in that day. And we have a range here based off of lights, a life cycle, right? So the clone phase of cannabis, when they're little babies getting rooted, 3 to 5 DLI or 50 to 80 PPFD, so very low light levels. And then we have to acclimate the plant as it grows to higher and higher levels of light. So vegetative growth is 26 to 38 DLI, that's 400 to 600 PPFD. And in flowering phase, this can vary quite considerably, but for fresh market competitive premium products, and highest yields, we're recommending between 38 and 65 DLI, which is a PPFD of 900 to 1500 over a 12-hour period. Note that 600 in veg is producing the same number of DLI as 900 in flower. That's because you have an 18-hour period in veg and you have a 12-hour period in flower. So it's the amount of time that intensity can accumulate changes, the amount of light that actually builds up. So we have PPFD, DLI, and then the point of this talk is energy. So let's talk about efficacy. So we're spending electricity when we're using lighting to produce those photons. We can spend more or less energy to make the same amount. So that's a measure of efficacy. Efficacy is the amount of photons you're making for the amount of energy that you're spending. And the range on that right now is somewhere between 0.8 for the most inefficient lighting sources that we have out there, incandescent, really, really crappy HPS, up to about 3.8 with the most modern LED lighting systems. The big segregator right now in efficacy has to do with legacy versus LED lighting. Your HPS, your CMH, your HID lighting in general maxes out about 1.9. You might see a brand new bulb brand new fixture, most expensive equipment, somewhere in the 2 range. But in general, that's the cutoff. LED lighting starts there and continuously gets more efficient. So the technology is your number 1 differentiator. If we go on to the next slide. And before we dive into the nitty-gritties of the fixtures and the lighting and the efficacies and the measures, I think it's important just to take a step back and ask the question, why? Why do we need supplemental light? And what does light do for us in general? Well, quality, I think, is the number 1 reason to drive high intensity light. Talk a lot about yield, and it's true, and I have my next slide is about yield, but increasingly in cannabis, quality is critical. We need cannabis that looks good on the market, that has good structure, that works well in our harvest patterns, it can be trimmed easily, packages well, maintains its value, and has high levels of the secondary metabolites that we're looking for. Cannabis flower grows the same way that the plant does. It stretches under low light, it's compact under high light. So light and light intensity and light penetration drives product quality. This is a photosynthetically active product. The harvestable portion actually uses light to grow itself. So it's really important that you get light into the crop to drive development, particularly throughout the whole crop. Next, please. So, and again, right? So there's how good the product is, and there's how much you grow of it. Us, Bruce Bugbee, a number of other people have shown that cannabis does have an insatiable appetite for light. So under optimized environmental conditions, it will continue to yield more and more and more. And again, optimized. If you have a poor environment, you can't utilize high light. So there's definitely a lot of work that goes into that. But in general, while each cultivar may yield more or less, the trend is as you increase light, you increase yield. So the quality and quantity that you're going to be able to grow is directly related to the amount of light that you put on it. And as greenhouse growers, one of the primary issues that you face is that light is variable throughout the year. So you need supplemental light in order to have consistent production of high quality products. Next slide, please. Okay, so back to this concept of energy and efficacy. Again, right, we measure micromoles per joule. I gave you that range of 1.9 to 3.8. The quality of light that you're putting out has a direct impact on the efficacy of a fixture. Blue light is harder to make from an energy standpoint than red light. So you can produce more red light with the same energy than you can blue light, which means that if you shift your fixtures more and more and more into the red spectrum, you're going to either put out more light for the same power, or you're going to spend less energy to achieve the same light target. So if you look at some of the spectrums that Fluence offers, this is our R4 spectrum. It's our broad white light. It appears as white light to the eye, 40% red. It's a 2.7 micromole per joule efficacy. If you go all the way down here to our R9B, which is 90% red, you'll see that it's 3.6. So one of the strategies that you can use in agriculture to drive efficacy is to push red. It's also a strategy that light manufacturers use to advertise more and more efficient spectrums. So you might think to yourself, okay, great, I want to get the most light possible. There are reasons that you have to consider outside of just efficacy when growing a plant. Next slide, please. So what we have seen is that cannabis has a morphological response to red light. On the left here, I apologize, this was supposed to be animated and the right side come in later. So let's focus over on the left here. On the left here, here's a cultivar. These cultivars were grown in the same space at the same time under 2 different spectra. On the left is a white light, and on the right is our R8 red light, so 80% red. A couple of things to notice. First off, look, morphologically, they're very different. The crop on the right is foxtail, right? So it has calyxes that are stacking on top of each other. The bud is not nearly as dense. The other thing you'll notice is that there's this white tip, which we zoomed in on here. That's called photo bleaching. So there's a point where red light can cause the chlorophyll to degrade inside of the plant. And when this dries up, it looks like botrytis. It is a very visually unappealing look. Chemically, doesn't really seem to have an impact, but visually very unappealing. The other thing to note about red light is if you look over here, here's the RH spectrum with that crop, and then here's the hall lights turned on. Look at how much more difficult it is to resolve the colors of the plant. So not only do you have to think about the plant and its response, but think about the working environment of your laborers. Cannabis is a very labor-intensive crop that often requires trimming and pruning and other activities that require visual acuity. Under red light conditions, it can be difficult sometimes to do that, particularly with things like pest scouting and pathogen scouting. So you got to think about your working environment as well. Now, talking about that photo bleaching effect and red light, we've been looking into this. We still are. Bruce Bugby's done some work on this as well. What we have found is that it's the total amount of red light delivered, regardless of what your actual total intensity is, that really drives the photo bleaching behavior. There are interactions, but that seems to be the primary driver. And in a study where we looked at a bunch of different red light fractions and intensities, what we saw was that in our indoor grow, when we crossed over 21.5 moles per day, that's a DLI, of just red light, regardless of how much other light there was in a white light background, we started to see photo bleaching. But below that, we saw nothing, no, at all. So you really need to pay attention to the amount of red light that you're adding, which is going to change as your intensity changes. So if I have a large amount of light, then I can use a smaller fraction of red than if I have a small amount of light. As greenhouse growers, you also have to keep track of the fact that the sun is about 35% red, and the sun changes in intensity throughout the year. So when you're designing your lighting, you need to account for that variability when you build in your supplemental light. So for now, what we're suggesting is that if you're growing for market flower production and you're going to sell dried flower, that you keep your supplemental lighting under a 50% red fraction when you're putting more than 500 ppfd of top light in a greenhouse for supplemental. And that's just kind of a rule of thumb at the moment that seems to be working pretty well. If you're not growing for fresh market and you're just doing extract, you can push a lot more red because you don't care about how it appears or how it appears. But if you care about the market flower, then that's something you might want to consider. Next slide, please. Ooh, this got a little jumbled. Okay, so as a closing thought here, I wanted to talk a little bit about the impact of efficacy on a design. So here I've got two lighting layouts. Each of these layouts is achieving the same level of light. On the top, we're using a 1.9, so we'll call this just a HPS design. These are designed, as you can see on the table down here, to hit 32 moles a day of supplemental. So that's going to give you something between a 40 and a 50 DLI target throughout the whole year. When I achieve the same light level in this greenhouse bay with a 2.7 efficacy fixture, you can see that the number of fixtures significantly reduces. So if we kind of take a look at the numbers down here of a 1.9, a 2.3, and a 2.7, same light levels, you can see that I need a fixture for every 20 square feet when I'm using a 1.9, and that drops to 27 square feet when I'm using a 2.7 efficacy. The other thing that changes is the amount of power that I use to drive those lights. I need 49.5 watts per square foot with a 1.9 efficacy fixture in this design, but I'm only using 36.6 watts per square foot when I'm using a 2.7. So there's about a 40% difference in power consumption to achieve the same amount of light. Click, please. So what does that mean for a producer? First off, that lower power consumption has a number of important considerations. You're using 20 to 40% less electricity. And that also means you're putting out less heat. And in the summer, in July, August, if you're running those lights on a cloudy day and you still have a bunch of infrared heat coming in, that can have serious implications to your crop. The other thing that really matters is that when you're designing for an environment and you're thinking about cooling, you're going to put out less heat, so you have less demand for your equipment. Your evaporative walls, your HVAC can be smaller, so you're spending less money on that equipment. Same deal for your primary power. You need less power to come on site. We know that power is a limiting factor in construction right now. So you can drive the same amount of light with a lot less. So your CapEx for a build out is reduced when you use a more efficacious fixture. And then finally, as I mentioned, right, the heat stress is really critical to cannabis development to manage heat appropriately. When you have high efficiency LEDs, you're not putting infrared light on the crop. You're just putting photons in, and you're putting less heat out from the fixtures themselves. So it's a lot easier to control canopy temperatures. The fixture count also matters. The install costs of hanging a fixture are reduced because you're hanging fewer fixtures. So you have less crews in there. You need less J boxes, so your electrical infrastructure is actually more affordable when you have fewer fixtures for the same amount of light. And also, as you start to get more and more fixtures hanging off the ceiling, you're getting less and less natural sun coming through. So you have less obstruction from those fixtures hanging. And then finally, LED lighting comes with dimming control. It's a pretty common feature. Now, from manufacturer to model, the amount that you can dim, how good that dimming is it varies. For us, tier 1 manufacturers like ourselves, Gavita, et cetera, we're usually dimmable down to 10% with no change in efficacy or spectrum. They have a lot of control, and that control can tie into climate control systems and holistic facility management and allow you to create a more energy efficient space that has better environment throughout the day. Specifically in that you can dim your fixtures down to reduce heat and manage heat dynamically. You can use predictive DLI algorithms to maintain consistent light levels so you're not overshooting and spending more energy than you need. And finally, you can use that in combination with shade curtains and other technologies to make sure that you're acclimating your plant to light as it grows so that you're optimizing that growth pattern and not stressing out your plants. So these new efficacious technologies also come with increased control. All right, that's what I got for you guys. So I'm going to turn it back over to Rob.
Jason, that was just great. I'd also point out the audience that LEDs, as a grower, you'll love them compared to high pressure sodium for how lightweight they are and how they don't require as much maintenance. I mean, it's just, they were such a breath of fresh air when I switched to them. Also, that dimming feature makes the fixture, makes the luminary more efficacious, doesn't it, Jason? That when you dim it, it's actually improving the efficacy.
A lot of the times, the efficacy actually doesn't change as you dim it down. It remains consistent. So it actually is more efficacious compared to HPS, because when you dim down, when you power down an HPS, they don't run as efficiently for the same wattage. So it's just that you maintain the fixture rating across the entire range of light output.
Excellent, thank you. Answer to our first knowledge check is that a greenhouse has more insect and disease problems. Carmen, do we have the stats on that? Yeah, look at that. You guys did great. And I know sometimes it seems like it wouldn't, but because the greenhouse is perfect for plant growth, it's also perfect for insects and diseases. And also outdoors, you've got wind that blows insects away and beneficial insects that eat insects. You don't usually have those coming into your greenhouse. Next slide. And before we get to Paul, I'm going to ask another poll question. All right, if you would all leave this up, and if you would answer this while Paul's speaking, we'll go over it at the end of the section. Paul Rena, take it away, please.
Thank you, Rob. Hello again. I'm Paul. Shade curtains and climate screens are more of a greenhouse relevant application, but towards the end of what I'm going to talk about, I'm going to talk a little bit about vertical airflow, which also applies to indoor growers. So don't tune out. It's still relevant information, even if you're growing indoors. So I'm going to be talking a lot about the way shade, diffusion, and blackout screens actually are useful within production. Blackout screens are pretty straightforward. You need to have light depth. And that's a necessity for cannabis growing. But there's materials associated with it that some people might not be aware of. I'm not going to talk too much about energy efficiency until the very end. But for now, all you need to know is that climate screens, when closed, save you on your energy bills. So using a climate screen day or night, depending on the screen, it's always going to retain heat in a greenhouse, as if it's another thermal layer. So just keep that in mind, and I'll go into more detail about that later. Next slide, please. All right, so in the past, shading screens served the primary purpose of cooling the greenhouse. For certain growers, it's considered a necessity purely for temperature control. Greenhouses are designed to warm up when the sun is out, and naturally that's going to warm up because of the radiation levels. It's going to increase. So if your crop has an imbalance caused by excessive temperature or light, you risk damaging the crop and can cause it to wilt or burn. And shading prevents that direct radiation, which puts the crop in a more comfortable area to grow. Shade screens naturally have a diffusive property to them, and generally the higher the shade level, the higher the level of diffusion. Shade screens with diffusion designed into them can provide a lot more benefits to growers than what they might realize. Simply put, diffused light creates a more productive and evenly growing crop, which can lead to a stronger, healthier plant with more consistent bud size because there's just more available light to the plant. Next slide, please. Okay. Screens with metallic strips on the right side were once thought to be the go-to for shading because it literally reflected sunlight away from the greenhouse. But we've proven that this is not the case when compared to shade screens that use white strips. Aluminum strips are more for heat retention, but white strips are better at reflecting, and they hold a lot less heat. I guess you can compare this to touching a hot car. Like if you're inside of a car and it's warm, the metal's hot. It's the best comparison I can make. Next slide, please. So during a trial we conducted in 2015, we discovered that on average, white shade screens can provide up to 5 degrees Celsius or 9 degrees Fahrenheit lower temperatures under the screen when compared to aluminum screens. Aluminum screens can be used for shade, but they serve a better purpose when combined with retaining heat in the wintertime or in colder climates due to their low emissivity properties. And if you don't know what low emissivity means, it basically means it's an insulative barrier that prevents heat from going through it with radiation or convection, but not conduction. Kind of irrelevant, but if you're warming up your greenhouse through conduction, that's not normal. But oh, I'm so sorry, I just kicked my desk. So yeah, white strip screens are better at reflecting sunlight in comparison to aluminum. Next slide, please. So let's go into detail on diffused light. Diffused light is not a reduction in the amount of light, but it's an even spreading of light that can reach farther down into your crop canopy. Direct light isn't bad for your crop, but diffusion screens will help make your crop use light more efficiently. When balanced with a shading screen to control temperature, it can be very useful as a tool in growing a very, very strong cannabis crop. Next slide, please. Diffused light used to be measured in its haze percentage, but today it's measured in something called Horty scatter. Haze is actually the amount of light that is available in a small window of about 2.5 degrees away from its original source, where Horty scatter is the full three-dimensional light that is spread out and given a property called a hemispherical transmission as it passes through a surface. So this is that shotgun effect of photons of the light that's actually being diffused into the greenhouse and becomes available to the plant. Next slide, please. Here is a visual example of direct versus diffused light. The picture on the left has a greenhouse with the shade screen open, and in the same location, they closed the shade screen. This shade screen specifically is our Harmony 2047, 20% shade, 47% energy savings, and the FR means it's fire resistant. Harmony is just the screen family name. It's a special kind of screen that's been designed to have a very low shade level to not limit too much light coming in, but has a very high, in comparison, Horty scatter percentage. So this is useful for the greenhouse growers that want to get as much natural light in to as much of the crop as they possibly can. So the obvious difference here is that the Harmony 2047 eliminates the shadows almost entirely when it's deployed. And with less shadowing, you've now given more light to more leaves within the crop. All right, next slide. Now, light deprivation and blackout screens. This is a must if you're growing in a greenhouse and you're relying on a lot of natural light because you need to limit the amount of light to your crop. Next, please. Now, there's different types of light deprivation screens or blackout screens. A light deprivation screen isn't normally single layered. If you're looking for a blackout screen, you don't want to get a single layer screen because that only blocks 99% of the light. That extra 1% could prevent your flower bud from developing. You'd want to look for a double layer or a triple layer screen because that will block up to 100% of the light coming in and will initiate flowering during your bud development. Next slide, please. Within those layers, you can have different combinations of different materials. So black layers absorb and restrict interior light and sunlight. Aluminum layers are the ideal option for growers that want to save as much energy as they can on their energy bill. It retains a lot more heat. There's a white reflective upper layer option if you want to maximize the amount of cooling in the summertime or if it's in a warmer climate. And then you have the option to have a white on top, white on bottom, which reflects the sunlight on top, but the white layer on the bottom, if you're running supplemental lights, it also reflects the supplemental lighting back down. And as Jason said, for every 1% of light, you get 1% of yield. You can reflect up to 7% more of that light back down. So it's not getting lost into a black screen. Next slide, please. All right, now when deploying a blackout screen, the main concern within the environment is your humidity levels. So humidity is one of the 3 environmental factors within your greenhouse that must be monitored and managed. If it goes unchecked, you can easily lose a crop to something like botrytis. The main concern when using light deprivation screens is airflow and humidity control. When using light dep, you're now creating a barrier across your vents if you're using roof vents, which is pretty common. A quality blackout screen is one that breathes. And by this, I mean that the screen can transfer moisture through it to balance out the absolute humidity levels from a higher humidity level, which would naturally be below your screen, to a lower humidity level, which would be above your screen. This is achieved just by the yarns within the screen and the physics of the way it's built. If you think about that little experiment we used to do when we were kids with the cup of water and the empty cup and the string going across, the water will naturally just move because it's going to an area with less moisture and it's being absorbed through the string. That's a similar effect of these screens when you're trying to balance it out. But I need to emphasize that this is not a reliable or effective method of dehumidifying your greenhouse. You need to have other means to do it. Although it's not reliable, it's still a valuable feature within a blackout screen that you should be aware of. Traditionally, gapping your screens is the main method of dehumidifying, but when you need to do light deprivation, that's impossible because you need to keep the screen closed. So when you're asking yourself the question, if you're just starting out, or if you have a means to install ventilation underneath your screens, that's what you're going to need to do. You need to control that environment below your screens to get that done. And as I mentioned before, we don't just sell climate screens. We also have a vertical airflow system, Carmen, if you hit next, that could accomplish this without having to open your screen, but still introduces air from a vent from above. So this is what we would consider in colder climates a dehumidification unit that's It can work in tandem with HVAC systems, and it can't replace a full HVAC system, but it relies a lot on the natural airflow within the greenhouse. So this is a vertical airflow system, and we recommend this as an air mover for crops like cannabis because they penetrate canopies more effectively in comparison to horizontal airflow. Traditionally, horizontal airflow is installed above, it blows air across the top, and it's really only affecting the top layer of the greenhouse or of the canopy. Vertical airflow is more effective at penetrating the crop to get a full vertical profile within it. Pictured here is our unit we call ClimaFlow. This introduces cool, dry air into the greenhouse without the need to gap because it's attached to the truss and it has a thin profile that the screen closes against. Now, this doesn't force cool air onto the crop, but it instead mixes it with the humid air to lower its absolute humidity, and then it's cycled through the crop canopy to create a homogeneous dehumidified climate. This is one of the newer technologies that is really being pushed a lot in Canada. It's one of the things we're trying to promote to help dehumidify because light depth up there is an issue and humidity is an even bigger issue. So this is a newer, more efficient technology that could help out a lot of cannabis growers. Next, please. All right, so how does this translate to energy efficiency? As I said before, closing a climate screen retains heat in the greenhouse. Most growers prefer to try and stick with something called a closed structure climate screen. That's the one that retains heat. If you look for something that wants an open structure, that's mainly meant for humidity control and airflow, but that will not retain heat at all. So the longer you keep these closed structured screens closed for, the more energy you save. Each of our screens has an energy saving rating attached to its title. A lot of the times we'll get growers asking for U values or R values, but we do all the work for that. I know it's kind of that like, oh, you'll save this much energy, but if people are tech savvy or have a bit of engineering, they'd obviously want to do the math themselves. We calculated each of our screens through very intensive tests at Wageningen University in the Netherlands, and we give them an energy rating. So for example, the Harmony 2047 screen, which I showed before, that 47% energy savings is the amount of energy you will save during the time that screen is closed. Every time you open the screen, it drops that energy savings down. So on the screen here is it's an example of what I do a lot. I personally run energy models and scenarios per growing operation that can show the estimated energy savings and ROIs of installing a single, double, or triple screen system. Many factors go into this calculation, from specific climates of the greenhouse to the sidewall material. This is just an example of the output of the report. This isn't the actual calculator, but this is a really useful tool for growers that want to understand how much energy consumption they're using. And it's a document that you can provide to your local utility if you're considering getting climate screens and you want a rebate. So this is the evidence and proof that you can be like, hey, this is how much energy I'm going to save. Please give me money. So if you would like an energy report, like I said, it's a lot of my desk work. All you have to do is fill out a quick online form. The more detail you provide in the form, the more accurate the calculation will be. And then we can work together on a one-on-one screening solution that can maximize your energy savings while accommodating for all the climate factors within your greenhouse, like temperature, light, and humidity. Thank you.
Paul, very informative. Thank you. That was new information for me on the metal strips retaining more heat. That's a new one for me. And I would second the idea of a breathable light depth curtain, because I've had cheap curtains before where we open them up in the morning and just like a rain of condensation falls off of it. So you just know you are asking for botrytis or other diseases. So
Oh, yeah.
thank you much for that.
Of course.
Carmen, go ahead. All right, we will look at the answer to our poll question. Was the focus of the upcoming year? It is saving energy with 47%. And of course, most of you are just starting out. So that is second place. Very good. Next slide, please. I think we're going to do a knowledge check before Dane's going to do his presentation on water quality. So knowledge check: some greenhouse curtains can be used for both shading in the day and retaining heat at night. True or false? We'll keep that open. And meanwhile, we'll turn it over to Dane Sheldon. Take it away, Dane.
All right. Good afternoon again, everybody. So I'm going to be covering a bit on water efficiency, the relationship with water consumption, energy consumption, and we're going to keep it pretty high level today. We only have about 15 minutes. Following this, these slides are going to be available. I'm always available for a follow-up discussion, and then RII will be publishing a much broader, more comprehensive guide on water circularity and opportunities in CEA this summer, which would be a great resource. But to start out, I just wanted to frame the topic a little bit on why consider efficiency in your own operation. The gist of this slide is really to get across, obviously, water, particularly fresh water, it's a limited resource on this planet. We all need it every day. And so I think no one would disagree with the statement that wherever we can conserve it, we should try to do so. That being said, as many of you are just starting out in your operations as small business owners, particularly in this area of cannabis cultivation, it's important to make sure that whatever you do to purify, conserve water is also going to allow you to continue to be in business, ride out any downturns in the industry, and avoid being non-competitive in what can be a fairly competitive marketplace. The old adage, everyone's always looking for things to be faster, cheaper, and greener. That certainly holds for this industry. So the objective of any facility water management strategy should be to identify opportunities to economically reduce, reuse, or recycle water with a focus on economical, looking at capital costs, looking at ongoing operational costs. So if you go to the next slide, Carmen. Today, like I said, we're going to keep it high level, just focus on the basics. For any one of these operations, you're going to need a reliable source of irrigation water each and every day. You're going to be generating a waste stream, which we'll talk through. And so you'll need a way to manage that water. And obviously, as any business venture, you're going to be looking to achieve this as efficiently as possible, both from the cost and from the resource intensity perspective. So if you take one thing away from this, I would say when building a new facility, or in New York, I understand there's probably going to be a lot of retrofitting of existing structures. You will do yourselves a lot of favors by considering your water management strategy at the outset, looking for opportunities to recover, recapture, segregate different water streams. And even if you aren't going to do it from day one, having that thought process when you're setting up your facility is going to pay out considerably as you get your operation up and running, and avoid kind of costly rework, reconfiguration, or missed opportunities down the line. So next slide, Carmen. Just before we dive in, I'll give you a little bit of jargon as it relates to water. There's many things you can measure in water. It can be fairly complicated. The devil is definitely in the details, but at a high level, what often you're looking at when it comes to water quality are total suspended solids, TSS. Those are the things that you can see mostly in water, either with the naked eye or under low magnification. Things like sand, organics, bugs, whatever might be picked up in your facility. Total dissolved solids. So these are dissolved organic and inorganic constituents that are present in the water. This is what causes water hardness, metals, salts, your nutrients that contribute to the EC or electrical conductivity, those are dissolved solids. And then there's colony forming units, viruses, microbes. That's the biological component of your water. And so just understanding these things when looking at water reports, you'll often see these types of metrics. These are kind of the primary buckets. And then when considering what you're going to do to the water, whether it's for initial purification or looking at recovery, it's important to consider what's in your water in order to select the appropriate technology. So the chart on the right just shows some common contaminants, the range of size of those contaminants in microns, as well as some of the technologies that are available to remove those. Everything from particle filtration, things like cartridge filters, bag filters, multimedia filters, up into membrane technology, which is the micro, ultra, nano, and reverse osmosis, which is a barrier essentially with decreasing pore size as you go from right to left, and thus removing smaller and smaller particles. And then there's things like ion exchange resin, which removes dissolved salts, metals, that kind of thing from your water. Just to give you a reference in terms of water quality, when you're looking at TDS, low TDS treated water is in the 0 to maybe 100 parts per million or milligrams per liter. As you go above that, you're getting into common city water type supplies or hard water. And then up into the 300, 400, 500 plus range, that would be considered high dissolved solids. All right, next slide, Carmen. So starting out with irrigation feed water, like I said, you're going to need a lot of water, you're going to need it consistently, and you can't not have it. So when thinking about a system, reliability, and some type of a alternative supply in the case that your primary supply is unreliable, these are important things to consider. The quality of your incoming water is going to depend on a few different variables, source being one of them. Are you getting it from a city water supply, a well, rainwater capture and collection, or some other source? The location, where are you? In New York, many parts of New York, you probably have great water quality. In other parts, it might be lower. Certainly in some parts of the country, the water quality is quite poor. And then consider seasonal variability. In the winter months, we often get lower quality water up here in the Northeast, people putting salt on roads, runoff into reservoirs. You do see a change based on the season. So it's something to consider in terms of the quality, consistency of your water. So the key takeaway really from here, though, is these variables, along with your own preferences and experiences, should drive what you're going to do to treat incoming water. Everything you do to treat will probably impact your ongoing costs and your energy consumption. So it's important to consider these things and be specific about what you need to remove from the water in selection of your system design. Next slide. So just touching a bit more on the considerations in terms of primary irrigation water design. Depending on the reliability of your source, on-site storage may be beneficial, particularly if you're relying on something like rain, or in some cases wells, which can have different production rates. Some type of storage to get you through a low flow or a low precipitation period will be important. If you are storing water, you want to avoid stagnation. Stagnation is the enemy. It breeds microbial growth. Think of a swamp versus a river. You want to keep things moving. That goes for distribution piping as well. If you're sending water out through your facility, it's best to have a loop where that water is continuously circulating through and coming back so that it's not stagnating in deadheads. You want to size a treatment system with some type of margin for error, and also room for future growth. It would be a shame to design, build, install a whole system, and then 6 months into production with increased demand, you need to buy a whole new system or upscale. Something, just a note on, sorry, just back on the previous slide, a note on reverse osmosis, if you are considering that. Pre-treatment and conditioning is critical to performance of those systems. Things like water temperature, chlorine content, solids removal, all of this stuff really drives how efficient those systems are in terms of how much water they're rejecting. As it relates to temperature specifically, for every 2 degrees Fahrenheit drop in temperature from a 70-degree kind of standard, you get a 3% drop in efficiency. So in New York, for instance, if your incoming water is cold in the winter, you're going to need to heat that water up if you want to have any reasonable efficiency on RO. So really, for system design, there's no one-size-fits-all approach. It should be based on the water quality of your source water and also your requirements. If you're working with a water systems provider, to the degree that you can develop quantifiable specifications on what quality water you need, that will really help avoid unnecessary treatment. Keep in mind that the quality and volume specifications are definitely going to drive the capital and ongoing operational costs, as well as the preventative maintenance of these systems. And just spend the time at the start to determine what you need and get that right. So, because you'll be living with the system that you buy for quite some time. Next slide. Wastewater management. So you will be generating waste streams at an indoor facility. These could include HVAC condensate, irrigation leachate, water from periodic flushing of your plants, washdowns of tables and rooms, periodic sanitizations, and if you're using things like reverse osmosis, the reject stream from that. Again, the plan for management of these streams is going to depend on your location. Is there a sewer line? Are you going to be disposing to the ground, in which case you need a permit in New York? If you will be disposing of water to a POTW, a publicly owned treatment works, there's often effluent limits, volume limits on those types of things. And then also in New York State, I know the regulations haven't been finalized, but there is a section in the environmental plan about looking for opportunities for water efficiency, waste minimization. Key considerations here is just, what are my options? How might I want to manage waste? And then it's cut off there at the end, but how might I reduce or even eliminate the wastewater generated at my facility through reuse and reclamation practices? In terms of reclamation, I know people do get leery about reclamation, particularly in this in cannabis cultivation. The value of the product is high. Losing a product would be catastrophic. And so that's where it really comes down to making sure that you have the correct technologies to remove any target contaminants from your waste streams. Starting point for that is understanding what my waste streams are and what are in them. We listed a few common ones here, going from probably highest quality down to more complex, higher treatment costs. Starting point for any facility would be to look at HVAC condensate reclamation. This is a very high quality source of water. It's probably of higher quality than your incoming water supply, meaning it would require less treatment, lower treatment costs if you're going to be treating your incoming water. Some things you need to keep in mind though, just based on experience on projects we've worked on and others have worked on, is making sure you're monitoring the pH. It is distillate, so it has no buffering capacity. Anything that gets in it can swing the pH wildly. It can, because it's distillate, water's hungry when it's so pure. If the materials of construction of your air handling system are not compatible with that pure water, you can pick up some metals. Most modern air handling systems account for that, but it's something you'd want to look at. Third would be microbial growth. Again, anything that's sitting, that's stagnant, has the potential for microbial growth. And then in some cases, there have been examples of things like pesticides that have been sprayed in a room after a room has been cleared out, being picked up in the air handling system and then coming through in the recovered distillate. So that's just something, again, that you'd want to have provision for to remove as a matter of course from any distillate you're collecting, if that's a potential. Irrigation leachate, obviously interesting for reuse because it has the nutrient blend that you're looking for, that you're applying. It's a bit more complex in that the plants are going to uptake nutrients, micronutrients, probably inconsistently through time and depending on the contact with the media the water is passing through. So measuring the conductivity, EC, it's a bulk measurement, is pretty typical, and just redosing based on the deficit between the recovered leachate and your desired irrigation feed water. That being said, all EC isn't created equal, so you might have different levels of micronutrients or specific target nutrients in that mixed stream. If you're going to be recovering irrigation leachate, you're going to want to have a plan for ongoing monitoring of that leachate to understand what's actually making up that EC that you're measuring. And then you're likely going to want to have an option for stripping that down periodically back to a clean slate or getting rid of it to fill with fresh water. Processed water, periodic flushes, sanitizations, washdowns. Our recommendation is to segregate that water. Whatever's in it, you likely do not want going back to the plants, and you don't want to mix it with an otherwise high quality source because that's just going to up the volume of water you need to treat and the cost of treating it. There are options for recovering that water. Again, the bar is just a bit higher. And then RO reject, that is a concentrated waste stream. Limited options for recovery. Vacuum distillation is a potential technology, but there's a cost associated with that. Next slide. So I'll just run through these quickly. Again, you're going to have these for reference. I wanted to list a few of the relevant technologies for each of the target contaminant areas in water. For removal of suspended solids, there's filtration or there's membrane technology. Filtration is grabbing the suspended solids that is in the water. Membrane technology, you are pushing water through essentially a barrier of a specified pore size. So to do that, you need a pressurized feed, which is going to require energy. The smaller the pore size, the higher the pressure, the higher the energy consumption. You also risk blinding a membrane if you're sending streams that have too high solids loads to a membrane. You'll block out that whole surface. For removal of dissolved solids, ion exchange resins are an option. They do have a limited capacity, and so they need to be regenerated through time. Another option would be nanofiltration and reverse osmosis membranes. Again, pre-treatment on these is critical to performance, and there is a waste stream, whereas resins are 100% efficient. And then distillation is another option. For biological control, membrane technology is an option. Also UV, ozone, thermal disinfection, and then chemical disinfection is also an option. If you're using incoming city water, you likely have chlorine and chloramines. Also a focus these days is PFAS. Granular activated carbon is the best available technology for this. Finally, evaporation, vacuum distillation. The cost of these units is not insignificant, but they are great options for getting rid of candidate waste streams that aren't easily treatable with the above technologies. Out of the two, vacuum distillation is definitely the preferred technology as opposed to evaporation. These operate under a vacuum, so they boil off water at a much lower temperature, being much more energy efficient. And you also recover the distillate for reuse in your facility, as opposed to evaporators that just send steam out the roof. So just to wrap it all up, key takeaways: there really is no one size fits all approach. It's important to be specific about what you're trying to remove from the water, selecting the appropriate technologies to do so. There aren't a lot of new technologies available out there, but it's important to work with a company. If you're going to work with a water specialist company, that understands how to put them together in a way that they will be successful. Allocate the time and the resources at the outset to set yourself up for success. That's considering facility design, opportunities for recapture of candidate waste streams, and dedicating a space for water treatment equipment and storage equipment. I will definitely say that sustainable water practices can also be commercially advantageous, but it's important to keep in mind ongoing operational costs of any systems you put in there to make sure your operation is robust in the case of decreased pricing in the future for the product. These systems do require oversight and preventative maintenance. So consider your in-house capability. And if you're partnering with a water specialist company, work with one that provides ongoing service and support and isn't just turning the lights off after they install a system. And in general, when it comes to water treatment and reclamation, you want to keep it simple. As things get more complicated, there's a lot more oversight. There's a lot more required in-house expertise or opportunity for things to go wrong. And in this operation in particular, you need a reliable source of water. So I'll leave it at that and look forward to answering any questions you all have.
Great, thanks, Dane. Great mix of the high technology that we need to learn about, like the vacuum distillation units, and that's a whole new thing for me. But also you also balance that with the KISS principle, and that you've got to approach this and plan carefully so that you don't install more than you need now. Just do the planning and try to make smart decisions at the outset. Really great stuff. We're going to answer the knowledge check now. Look at that, 100%. Well done, everyone. We're going to move on through the resources section. Next slide. Just going to buzz through these quickly. And then since we've been answering, this has been so much fun. The panel has been answering the questions as they come up in the Q&A. So we don't have a long list of those, but I've got one question for each of the panelists that I'll cover after we get through the resources. So of course, the best practices guides, I referred to those. Those are free and those are available on our website. Next one, please. Also, if you want to contact us, if you want to do benchmarking of your resource use efficiency, this is kind of a printout, I should say, a screenshot of our PowerScore rating that you can see your KPIs. Next slide, please. Of course, here are the emails for our expert panelists. And again, you'll get this deck emailed to you, so you don't have to scribble all three of those down now. And you can reach out to them and they will be very, very helpful. And I would say that you're getting industry content, industry informed, boots on the ground content, but also, because I listen to these guys and see their work, it's also scientifically validated. So I would mention that. Next slide. Okay, actionable takeaways from today. LED lighting is often twice as efficient as HPS. Lighting impacts flower yield, flower quality, and plant architecture. So it's not just how much the plants grow. Diffused light increases yield by increasing light photons getting to that lower foliage. Excess humidity under light deprivation cloths must be mitigated or you'll be in big trouble. Water must not be allowed to stagnate, as Dane said, more like a river, not a pond or swamp. Or it would turn into a swamp if you don't keep it moving. And plan for multiple wastewater streams. If you're new at this, talk to the experts, because there's going to be, it's not just the water coming out the bottom of your pots. There's other water waste streams that you'll need to handle and comply with regulations. And there's also the opportunity to reuse some of those, like with HVAC condensate. Next slide, please. Okay. I'm going to ask each of you a question. We're going to wrap it up here. This has been so much fun. Jason, can you tell me a little bit about far red light? My impression for cannabis is that, or my fear is for cannabis, that far red, since it kind of stimulates the shade response, it makes the cannabis plants so tall they kind of get unwieldy. And I noticed you didn't talk about far red. Is that something you don't recommend for cannabis?
No, I think, first off, we are actively researching at Fluence. So It's a topic of interest. I think there's definitely a need for some, right? You don't want such tight internodal spacing that you create a microclimate enriched environment. So some percentage of far red is important. And if you look at, our 4 spectrum, which is pretty much the workhorse in cannabis for our company, and similar companies have modeled after that and are plus or minus, there's always a couple percentage points of far red in those specifically for that purpose. I think having an absence of far red is potentially detrimental to the crop. To that end, the question of what about far red at high concentrations? Yeah, I think you could potentially see some stretching. Is that a bad thing? I think that really comes down to what you're trying to achieve. There are so many cultivars in cannabis, each of which is so different in its growth behavior and response to the same stimuli as another, that could potentially be a tool. And we do see variable far red as something that is being used in other agricultural industries, particularly the floriculture industry now, as LED technologies give people control over far red, separate from other aspects of the light spectrum, to modify their crops and during different times of year. You're not getting a lot in the winter from the sun versus the summer. So I think that there's a place for far red. I will also say that I think that there's a lot of people trying to do very interesting things with far red. It's used by the plant to help determine day and night and to help with the triggering of the short day flowering response. I think there's a lot of YouTube channel type of videos and things about thumping plants with far red at the end of the day. And we've kind of looked at some of those off the wall applications, and by and large, our observation is that that can lead to some pretty challenging morphological and physiological responses. So I would not mess with far red as a steering tool aggressively, but rather look at simply providing a background level to support uniform plant development.
Great answer. See, things are never as simple as they appear. This is why it's fun to talk to folks who think about this every single day. Thanks, Jason. Paul, one of the reasons I say this jokingly, one of the reasons I was a good greenhouse manager was that I made every mistake that could be made, and luckily I'd learned from most of them. So you make so many mistakes. One of them was that I used to do these cookout treatments in the greenhouse when it was empty, so I could disinfect it using heat. But then I realized that was probably getting too hot for the shade curtain material. Is that true? And is there a temperature you would say you would want to go above in your greenhouse with curtains in it?
Elaborate a little bit on what you mean by cookout. Are you taking like
I'm sorry.
Torch to it?
I would crank the greenhouse up to, I would allow it to heat up to over 100 degrees, and up in the ceiling was probably 120, 130.
Okay. Well, there's different types of plastics that are within the screens. From what I know, I think the limitations can get up to about 70 degrees Celsius, or 60 or 70 degrees Celsius. That's when you start seeing deformation in the strips. But I don't recommend it. They're not meant to be overheated. There's probably more efficient methods of sanitizing the greenhouse, but overheating the space in concern of your climate screens is not recommended.
Right. So 60 C's, 140. I was probably getting close to that. And
Pretty
also,
close, yeah.
I should also say, before Jason reminds me, that you don't want your LED lights getting up to 140 degrees either. That's not good for your electronics.
So
yes,
fun. We do get that question, and actually, our fixtures can be they can be in a location in a non-operational state that gets to those temperatures. So they are compatible with heat sanitation unless you turn them on. If you turn them on and you run them at those temperatures, you will damage the electronics and void warranties. So they're totally fine to hang there, but I know I did the same thing when I was running old school greenhouses, right? You turn the HPS fixtures on too, right? And
Yeah,
put
of
some extra
course.
heat
Yeah.
in there. Don't use our fixtures as a heat source.
Excellent. And Dane, one question for you, where I always get confused once I think I know something, then I get confused. Tell me what a mixed resin bed is.
Yeah, so resin is essentially like a battery. It has a charge. It comes in an anionic or cationic form. The cation removes positively charged ions from water. The anion removes negatively charged ions from water. When they're separated into two different vessels, it's called split bed. When they're blended together specifically to treat the mix of an incoming water supply, you call that a mixed bed resin. And so it has the ability to remove positively and negatively charged ions from water.
Excellent. Thank you. We want to thank you all for attending today. And again, you'll get this slide deck in an email. And I want to thank Jason Matlock of Fluence, Paul Arena from Ludwig Svensson, and Dane Sheldon from Aquis Group, and Maggie Coey from the OCM. For Carmen Azaretti, I'm Rob Eddy, and this is Resource Innovation Institute. Thank you so much for attending today.